Let's now attempt to evaluate the hydrocarbon potential of our West Texas well. We focus our attention on the 56-foot thick carbonate formation defined by the gamma ray log. The neutron density combination log we looked at earlier indicated a 28-foot interval of porosity ranging between about 10 and 14% from here to here. Because the well was drilled with saltwater-based drilling mud, therefore a type of resistivity tool called a lateral log was run in the hole. In this case, a dual lateral log system was used, one that contains a shallow device to measure the resistivity of the invaded zone, as displayed by the solid curve, and a deep device designed to measure the resistivity of mostly the uninvaded zone, as displayed by the dashed curve. Our log presentation is on a logarithmic scale from 0.2 to 2,000 ohms. Note that the shallow lateral log reads significantly less resistivity, about 22 ohms here, than the deep lateral log, which reads about 40 ohms here, thus reflecting the influence of low resistivity saline mud filtrate in the invaded zone. The deep lateral log, with its higher resistivity reading, indicates possible hydrocarbons in the uninvaded zone. This is a computer-generated log of our West Texas example. This general interpretation model uses the density neutron, resistivity, and gamma ray logs, along with information on the resistivity of the formation water. On the left side of the log in track 1, the average grain density of the formation solids is recorded in grams per cubic centimeter. In track 2, we see a plot of the water saturation scaled from 0 to 100% in divisions of 20%. Note that at 5,064 feet, where we performed our manual calculation to arrive at a water saturation of 25%, the computer has determined about the same value. Also in this tract, we see an estimate of permeability, which provides an indication of the formation's productivity. We recall that permeability, generally measured in millidarcies, refers to the ease with which fluids flow through the formation. The permeability scale on this display is logarithmic and ranges from 0.1 to 10,000 millidarcies. Total absolute or intrinsic permeability is indicated by this solid line, and the portion of this absolute value, which is effective hydrocarbon permeability, is darkened. In track 3 is a porosity analysis showing total porosity scaled from 0 to 25% in divisions of 5%. Note that at 5,064 feet, the computed porosity is about 12%, which is the same as our calculated porosity. The relative portion of the total porosity which is occupied by hydrocarbon is darkened, and that portion occupied by water is shown in white. In track 4 on the right of the log, on a scale of 0 to 100%, we see a formation analysis showing the clay fraction, a matrix solids fraction, and the porosity fraction in white. Note that our productive interval is calculated to be shale-free,